And welcome to Emerald Metals, your one-stop channel for all things 3D printing, RC, and sometimes quilting. Today we're going to be talking about a 3D printed project. This is going to be an educational type of video for my teacher colleagues. As you know, a lot of you, most of my activities involve 3D printing. This is a new tricopter I'm working on. This is ABS. I printed this out completely. And this is going to be indoor. I'm just programming the controller card for it. This is a tricopter. This is made out of PLA. This one is more for outdoors. It's pretty big. We're going to see which one holds up better, the ABS or the PLA. Even the nuts on that PLA one, I actually printed out even the nut components. It was really nice. I put the bolts in, but actually the nuts, the tighteners, were all done in PLA as well. So kind of my projects working on it over the winter time. And when I'm not printing RC airplane type things, this is a wing assembly. This is also a spar wing assembly I'm working on. I don't know how this is going to turn out, but maybe I'll spend some time on this. Is all 3D printed. I've pretty much gone to trying to do anything I can with my hobby with 3D printing, because as you know, when you crash, and you do crash in this hobby, it's always so hard to wait to get parts. So a lot of times it's nice just to be able to go in and print your own parts and move on. Anyway, that's not why we're here today. We're going to talk about this cool little engine I found on Thingiverse, and I'm always fascinated by engines, and I thought, yeah, I'd give this a try. This is an air compressor engine, and you'll see a little video of it running at the end of this. It runs well, but I wanted to give you some tips as to what I did to print this out. It's an easy print. And follow the instructions. This gentleman actually knows, in my view, he's got all the right tolerances. He did a great job. A lot of people that look at the videos, look at the items on a Thingiverse and print them out and they don't work and they get frustrated. That's because not everything up there is gold. Some of it is just people's ideas and they've never been printed out. So you try to print them out and nothing happens. So this is basically the assembly, the upper and lower arms screwed together. The one thing I did differently is these bushings, I glued them in. I'm never taking this apart. So I think they separated it for printing reasons, but the bushings I glued in because they were loose. I ended actually making things a little bit sloppier by over sanding. So you need things to move freely, but don't do what I did and over sand. So things need to move freely. So these here bushings, I glued them in. They're solid. They're not going to rattle around in there very much at all. The nice thing about this is that the tolerances are really good. So all you need is just sandpaper to clean off any of the rough edges, especially in this little key on the crank here. There's a little burr on there that you have to clean off really well. So like I said, I kind of over sanded so things were a little bit looser than what you would want to do, but all in all, it is a great educational component because kids get to learn about 3D printing and how it works, and then a product, an engine, and how it works. How cool is that? Like if you're a teacher, it is definitely a win-win-win and win-win scenario. So, and the kids have fun doing these types of hands-on projects. So I'm just going to do a quick assembly here. It doesn't take long. And I'm going to, you notice here I over-sanded on the piston. This is the cylinder and this is the piston. I over-sanded. It's loose. Still works, but I need a lot more air pressure than I think you would really need to do. The other thing that I've done differently is in the instructions they recommend that there's a spring on here that holds the cylinder to the upper control arm. I didn't put a spring on, I just adjust it with my screw because it needs, the air comes in here, and when the cylinder is in this position here, the air goes in and blows the piston down, so you need to have kind of a fairly good fit here, but mine works fine without it, and the spring was actually too tight, and it wouldn't rotate back and forth, so I compromised and just took it out. The other thing that I've worked on, you see in the video, I have a lot of air pressure. This one here, this is from a dollar store can of compressed air. You do get some action on it, not as much as you'll see in the video with the air compressor, but for the classroom, this may be the ticket. I just glue gunned on the nozzle assembly from the dollar store, and your engine will work. It'll be pretty anemic when it works, but maybe that's going to be the best way that you're going to be able to do it for the classroom environment. So take a look at the video of it running. It is actually kind of cool when you print something out and it works. It really is a lot of fun. So I hope you've enjoyed this video, and if you did, please subscribe and like, and share this video with other teachers. It's always good to have projects that you know have been tested and worked, rather than you spending a lot of time and trying to figure out whether this is actually a good project or not. This is definitely a good project, and if I come across any more for teachers that I think would be good for them to use in a classroom environment, I will pass those along for you to print out. So all the links will be on the YouTube video. So enjoy, and we'll see you next time at Emerald Meadows. Have a great day. Bye-bye. So let's take a look at this in more detail. This is the this will show you how the engine operates now that we've looked at all the pieces. Pretty straightforward. You need an air source. You can try a can of air, or I have a compressor, so that kind of works. Goes pretty fast, goes down pretty slow. And it works great, works great. So that's the operation of the motor.